In this video, we're going to demonstrate setting up RS485 communication between two flex SCADA Q5 PLCs. In a previous video, we demonstrated using the RS485 port for Modbus communication, but in this example, we'll be using the RS485 port for raw data communication, similar to a serial port. Let's get started by connecting power and network to each of our devices. Let's also connect the two devices together through their RS485 port. So we can see here RS485A and B are the top two pins on each device. And we'll connect A to A and B to B, so it's just a straight through connection. And if there are multiple devices, you'd have A, B, B, B. Everything would be connected together like that. So let's log into our devices. So let's set up this device here to transmit data. So let's start off by initializing our serial port, serial.init, port 2, and 9600 baud rate. And let's create our main loop, while run. And let's do serial.tx, port 2, hello from A. And let's wait 3 seconds between each transmission. There we go. So let's go ahead and test that. So this device is going to send hello from A every 3 seconds. And on this device, let's set up to receive those messages. So serial.init, port 2 again, same baud rate, and serial.listen. So we're going to set up a callback handler. So this is a function that will be called anytime we're receiving data on the serial port. So let's listen on port 2 for this return character, and let's say data received. Let's call that function, and just print that data here too. And then let's create our main loop. And let's run this. We can see we're receiving those messages now. Hello from A. It was a 13-byte payload. It came in on port 2 and it was not overflowed. So this overflowed, if you have really large messages before you've sent this return character, you can overflow the internal buffer. And so you would know that there was an overflow, so that's useful. So we're receiving data just fine from our device. Let's go ahead and send over something more useful. Let's send the value of analog input channel 1. So let's do let value equal input 1. Let's get the instantaneous value, and let's convert that to a string, 4 decimal places. And let's just, over here, let's just add that terminating character onto the end. Let's go ahead and test that. Coming in here. So there we go, 0.0003 is our payload, 0.0016, which should be the same as what's on here. So let's go ahead and put a voltage on here just so we can see something a bit more useful. I have a 12-volt battery here. It's connected in on port 1. We should see that. There we go, 12.6427 volts coming in. And that's exactly what we're measuring over here as well. So this communication could go both ways. This device here could be sending data back as well. There's also, on this device here, we're just sending this right now as a simple string. That value could be sent as a encrypted value. There's demonstration examples here of AES encryption, so you could set your pre-shared key, you could encrypt a JSON payload, you could send like a encrypted data or hexadecimal. That's especially useful because it also offers checksumming. So if you have corruption on your serial port, you have checksum protection, you also have encryption on there. So especially useful. There are examples for all of that under the example section. And yeah, so this is just especially useful where you have situations where you want to communicate with equipment that doesn't support the Modbus protocol, or you have your own equipment that you want to communicate with, and being able to communicate that with that and also integrate that in with other devices and other protocols, say for example Modbus TCP, JSON, HTTP, or maybe you want to log that data to an SD card, or you want to log it in Grafana or InfluxDB. It kind of opens the door for all of that. So I hope you've appreciated this short demonstration of RS485 communication. And if you have any questions, feel free to reach out on our website, fluxgata.com, under the contact section. Thanks again for your time and for watching.